Okay. So let's assume that we have our user and password class, but the user is an email address. If I ask you what type of data type should we use for representing an email address? Let's see. George or Ali. Let's go for Ali. Ali, if I wanted to represent an email address, what data type or object should I choose?
If you represent,
What was it?
no idea, sir. I don't know.
You don't know? Let's see. Josh, what would you choose?
String.
A
Right.
string. That's correct. We would choose a string. Okay. But we know that a string, you can put A, B, C, D, E, F, and that's a string, right? Is this an email?
Not quite.
Okay. So it's not an email address. So what do we need to make an email address?
You could have like numbers and
I guess
Numbers?
like a symbol.
you can have like a symbol also.
Which symbol?
The at symbol.
Okay. An email has an at symbol. What else does an email have?
Period.
Okay, a period. What else?
And
Could we have numbers?
Yeah, well, it could be letters or numbers, but at the very least, we know that an email address needs to have an at sign and a dot. So if we were writing a class that it's going to take that, we can then store it as a string. Let's say username or user account. And the email string is what we are storing inside. And we cannot absorb this guy, right? Because that is not an email address. So we can't do this one, but we can do this one. So in order for us to protect our data and not make sure that we're not getting garbage in, garbage out, we need to encapsulate this guy so that we do not allow the variable to be overridden or done differently if it doesn't have the minimum criteria, which is having these two fields. So far, so good? Yeah, okay. So what we do in encapsulation is that we create a class, for example, this time the user or whatever, and we have an email, which is a private string. That private string will hold the value, and we have the freedom of restricting entry or access to it by whatever means that we have. If we validate that the data is correct, then email will be set up correctly. Let me then get some numbers from this point. Great, everybody's at a 9. Okay, so that is encapsulation. Actually, let's give this a go. I would like you guys, let me give you a couple minutes, or let's put like 3 minutes. I want you guys to copy this file into your IntelliJ. Okay, so once I unlock that encapsulation, I can go into yet another class that we're going to create, and we're going to call it class 6. And then in here, we're going to add the main method. And we're going to create an encapsulation object, which is referencing the file that we just created. And we're going to create a new encapsulation. If we did e dot set email, if we were to print get email. So if we right click and run it, we know that it got accepted via the getters and setters. The email is there, but what happens if I remove the @ sign? We get a null because nothing was created. So essentially this is validating that there's an email address by us essentially having that set up. I'm going to split it in both sides, and I'm going to give you a couple minutes to copy it. Well, let's leave 3, just so you guys get familiarized again with IntelliJ and I'm not moving too fast. Okay. Did everybody copy the entire exercise? Or does anybody need more time? Nobody? Okay. Basically, I just want to make sure that, like we can't, if we want to, we can't do a.email equals, anything, because the encapsulation is going to prevent us from, it says email has a private access in encapsulation. That means that the encapsulation file is blocking me from me to modify it. So by me implementing those things, I make it as compliant as possible. Okay. Let's continue to the next concept. Polymorphism. I'm sure George will actually know this one. George, what does it mean to be polymorphic? What does the word polymorphism mean?
I think this was when, like, child classes, they share some of the characteristics of the parent class.
That's inheritance.
Yeah. So, which one was this? I always confuse these two.
Yeah, it's okay. That's why we're reviewing this, so that I can try to help you navigate and make it better. Okay, so polymorphism is the way where we can have a class. Well, what the word polymorphism, it actually comes from, is it Latin or Greek? I think it's Latin. Let's see. If I remember correctly, let's see. Multis. No, then it would be multi. Okay, then let's see. Greek. Pola, which is poly, and then Greek for shape. Shima, okay. I thought morphos was figura. Let's see.
Right. Change, right? Change.
The what? Change?
Change, yeah.
No, no, no. It's on Greek. But there's another way. Let's see.
Form?
If I swap this and I wrote
What about form?
translate from Galician. Well, let's see. Form and let's swap. Morphe. Yeah, there you go. So it's multiple. Yeah, multiple ways. It's what it basically what the word translates to, multiple ways. And there's multiple ways to name the same function, the same thing over and over and over. Meaning, if we have a class like this, and we create a class called calculator, let me close this guy here, and we say set up the main method, and also we're gonna that public void, public int add. So what if we did it with ints and we wanted to return doubles, we could essentially change the signature of the function, but not the name, and get an answer, because we're adding support for many different shapes or many different forms. Now that is possible when the signature changes, and the signature is the part that I have highlighted. Why would the signature not include this? Can anybody have a wild guess why the signature needs to be different? And then why would that, in order for the signature to be different, it is not including the access mechanism and the return type? Who can tell me?
Can you, even if you have the same, like if you put a double in, if you put two doubles in, that doesn't mean you have to return a double, right?
The what?
Like you're giving the function two doubles, but that doesn't really necessarily mean you have to return a double.
No, but well, so here's the thing. If we call the function, let's say calculator C equals new calculator. And let's assume that let's ignore the compiler errors, right? But I had this.
Yeah.
And even if I did casting it all, so that the return type matters. Now you're gonna see that it still stays as a problem. Why? Because if I did
I guess it wouldn't know what to.
Which
exactly,
function?
which one would it choose between these two? I'm not including the return type here. All I'm including is the arguments.
Yeah. I don't know which one it would.
Huh?
I don't know. I'm not sure which one it would use first.
No, well, if you're not sure, the computer is even less sure. So that's the main reason why this is not included. The moment that we take care of that, like we only have one single function, you'll see how it actually picks it up. And it doesn't matter if it's this one or this one. Immediately it removes that error line.
So it is basing it on the parameter types?
It's just the parameters and the name.
Just Expand. Okay.
parameters or arguments or whatever extra names that we want to name things.
Okay.
So that is polymorphism, essentially in a nutshell, where we can reuse the same name and different arguments to name a function as something different, but that has the same name. Now, before then I continue to anything else, let's get some numbers of encapsulation and polymorphism, please.
So like a child class can still have its own implementation, right? Is it?
Yeah,
Like, okay.
yeah. And this is where then we go into inheritance. With inheritance, we briefly touched it on the previous session because we were previously touching on the previous session because we modified the square to become a rectangle and the rectangle to become I should put it here because I changed the camera on the side. Can you guys see yourselves on Zoom? Yeah. If I share the full screen, do you guys see yourselves?
I think so. Yeah.
Yeah. Okay. So are you seeing yourself now, like everybody on the?
Yeah.
Okay. Well, it's just like I changed the camera. I was using the one from the MacBook, but I got I think a slightly better one, and I keep looking here because I'm looking at you guys. So I'm gonna put you guys here, so I'm looking at you. Anyway, so inheritance essentially means that we are going to grab every property from the parent and put it on the child. Now, when we do that, we are moving from a world, and actually let me open this up on the whiteboard, but I want to open it up on Keynote because I want to highlight a couple things here. So on this slide, I'm going to make this a little bit bigger. On this slide, when we are moving from this, the cable is getting on the way. Let me do it here. From top to bottom, when we're moving from here to here, we are going to have, say, the dessert is going to be much more abstract. And the further down that we go, it's going to be more concrete. So our classes become more concrete the further we climb down from the top of the tree all the way down. Example. In some places, sometimes like if you get an orange, that could be considered a dessert. But it's not necessarily fitting in all these categories. Dessert is much more higher level than raspberry cheesecake. That's extremely concrete. Like if I were to ask you guys, Jose, what is your favorite dessert?
Cookies.
Okay, cookies. What kind of cookies? Still doesn't tell me enough.
Chocolate chip cookies.
Okay, that's very concrete. If Jose said, I'm gonna go get some chocolate chip cookies, we know exactly what he's getting. But if he says, I'm gonna go buy a cake, there's a chance you might like what he buys. There's a chance you might not, right? So the further up that we go, the more abstract it is. The further down we go, the more concrete it is. When we are also talking about in terms of abstractfulness and concreteness, there are other aspects that we need to keep in touch. or in place. But before we're going to revisit that part once we are looking at some other elements. So for now, we understand that, you know, we are going from an abstract level all the way down to a concrete level. So far, so good. Whenever we are using the keyword extends, that's when we're dealing with inheritance. So, and this is an example that, for example, the class vehicle is a higher level. It's a much more abstract level than the class car, because vehicle can include planes, vehicle can include motorcycles, vehicle can include a bus. But a car is, you know, it's another level down of a family of objects. And then if we say red Mustang, it's much more concrete. So we're going from like the abstract to the concrete. So you can see that, for example, in this case, the class car extends from vehicle. That means that it's going to copy everything from this class and put it on this one down here. And as we are calling, for example, attributes car, we can call this dot attributes, which is another method that was not defined on this part. It was defined here, but it accepts it. And then it's going to print the gear and the car. So you're going to see like every single attribute is printed for that class, even though that for car, not everything was defined. It was inherited. So with that in mind, let me get some numbers about inheritance so far. Okay. With inheritance, and we know not only with inheritance actually in general, but if we, that this, what was I going to say? With oh yes, that any object, any instance, right? Let's say this is an instance of an object. What do we call the pointer that points to itself? What do we call it?
This?
This, correct. This is a pointer that it, but at some point, there has to be, you know, if we're extending, let's say this is car and this is vehicle, and this is just a class because we're extending from that class. We need to figure out a way if this connection exists. The connection where we say extends. So every instance, what it does is that when it's created, when it's instantiated, it creates a reference to the parent class that it came from. Essentially, similar to this, we are creating a pointer that is known as super. That's pointing to the ancestor. Now, it doesn't point to an instance of the ancestor because when we created the object, we did not create an instance. We just said extends from this class, but we did not create an instance for the parent as well. So we're just essentially referencing the class. Why would that be valuable? Well, let's assume that we are writing a software for a freeway, right? And in that freeway, we say that motored, or let's say cars and motorcycles are allowed. Actually, the better way would be to do it this way. Wheels, ground, vehicles. That's still a very, even though that it's much more concrete than vehicle, that it is an actual subclass of vehicles. Now, let me redraw this. So I need the space. So we have vehicle, and we have wheeled vehicle. We can say for a different one, winged vehicle. And then this would be like water vehicle. And then we can even put one like, let's say, for the Mars rover, outer space vehicle. Why would I classify them this way? Because it makes it easier to subclass. So for example, winged, or actually instead of naming it, let's even rename wheeled vehicle, because technically an airplane has wheels. We're gonna name them ground vehicle. We're gonna name this air vehicle. And now we have outer space and water vehicle. So for example, here we could have a vote. We can have a yacht. We can have a kayak. We can have all sorts of different water vehicles. For air vehicle, give me some examples, guys.
A jet.
Okay, a jet. What else?
Helicopter.
Okay, getting the chopper. What else?
Airplane.
Well, airplane would actually land on jet, but we can say a glider, right? Like one of those hang gliders. That could be a winged vehicle. Ground vehicle. Give me some samples of ground vehicles.
Motorcycle.
Okay. What else?
Truck.
Okay. What else?
Bike.
Yeah, sedan, a bike. Okay. Yeah. Now, if we were building this guy, the freeway, we could say that ground vehicles can go on that road. So for the very particular case of, say, let's find out what is a cool Harley, or unless anybody here has any ideas. I still haven't gotten the midlife crisis yet, thank God. But let's say just to keep you guys entertained, let's go into the Harley Davidson. And let's just go for the street ones. The Iron. Oh, I think I'm gonna get a middle life crisis sometime soon then. Okay, so if we go for the Harley Iron 330, or let's go for a typical sedan car. I don't know. Let's see, BMW Series 3, just to throw something out there. And for the truck, the F-150. Doesn't matter if all these different cars are driving down the road, if we can say that ground vehicles are able to circulate on that road. So because all these are ground vehicles, we do need a way to figure out if all of these guys can trace their ancestry back to their parents. So that's what the super keyword does. So in effect, when we are using, oh, I deleted the part of the slide. In effect, when we are creating an instance, we have a pointer to itself as this. We have a pointer to the class, the immediate parent, that it's known as super. And even if we had the situation, as you saw on this example here, it's only pointing to the parent class, because in order for it to go, like, to continue traversing, the parent can call the parent, and the parent can call the parent, and the parent can call the parent, all the way up to the common object that everything derives from in Java, which is known as, what's the name of that class? Does anybody know?
Base class? I don't.
The what?
There's a
The
special
base
name
class?
for it?
Yeah, what would be the base class?
I guess the highest, the most abstract class.
Is
And
the
what
base
would
class?
that be in Java? If you were to name something, what would it be named?
Super.
Nope.
Java?
Java class.
Nope. It's named object. That's what the class means. Like, everything, even if you don't explicitly say public class 6, if we say that, basically it translates to public class, class 6 extends object. That part in red is basically added, even if you're not seeing it, it's basically added to every single object. What does the object class contain? Let's go into the browser. Where do I have a browser? Okay, here it is. You can go Java object API. There you go. Okay, so the class object is the root level object. There's nothing that inherits from that, and everything inherits from object, and it has just some basic information of, like, handling threading, to check if the actual uniqueness of the object, a method called equals that essentially verifies is the same object, if two objects that look similar are the same or not, and that's and a toString conversion. So everything is an object in Java, every single thing. Okay, we've discussed this, the object going super, and okay, let me then, Sareth was the one that knew everything, and I didn't see it. Sorry, Sareth. You're the one that were typing the Iron 1200, the drone, the Tesla, the Sportster, the primitive, and I didn't see it. Sorry about that. Anyway, so far, actually primitive, I think that was like, what was the name of the top object? And the top object is object, but object is made out of primitives or objects. So it's a little bit of a chicken and an egg situation. Okay, so now that we talked about this, let me just make sure that everybody understands what the reference to super is and everything that we've discussed so far before we go into code. Excellent. Okay. So let's assume, Jose told us that his favorite dessert were chocolate chip cookies, right? So he happened to, have lunch with Sareth last week, and he told them, well, my favorite dessert are actually chocolate chip cookies. So Sareth knew that we were going to be working on our Java class, and teamed up with George and Leon, and they designed this beautiful class that we have here. That it has a generic version of what a cookie should be. And as far as a cookie goes, we know the three amigos decided that they were going to define a cookie by having a shape. George is Italian, so ingredients are very important to Italian culture, and Leon wanted to make sure that we were able to name it, to make sure that we identified the cookie. So he wanted to also add a string to decide, okay, this is what we're going to name the new recipes. So Sareth was like, okay, all that is good and everything if we want to have the shape, but a shape is determined by a cookie cutter. So what we're going to do in our constructor method is that we're going to, in order for us to have a cookie, we need the ingredients and we need the cookie cutter. And that's how we're going to get our cookies. Then for us to create the cookies, we grab those ingredients, we mix them, and then we cut that cookie. And now we have a shape. Could be a triangle, could be just, a flat circle, whatever way that we want. Okay. And in that same conversation, Leon wanted to make sure that there was a minimum amount of folds that would happen on the mixing of the cookie. So he decided, well, I believe that the minimum necessary would be to mix it 5 times. And what we're going to do is that we're going to, in order for us to represent that, we are going to essentially swap the order a lot. Cool. And then they met with Ali, and Ali said, yes, this is what we're doing. This is great. However, once they brought it up to Brandon was like, guys, this is still very abstract. We need to make sure this is not Jose's favorite cookies. It's still just a cookie, generic. So why don't we change it a little bit so we can make the chocolate chip cookie? Okay, great. So what Brandon decided to do is to grab the work, because they of the three amigos who were working so hard on getting that recipe for the cookie ready. So he didn't want to start from scratch. He was like, you know what? If I learned anything in my Java class, that I was not supposed to be repeating myself. So so Brandon decided to extend the cookie and add an extra array of ingredients that is the chocolate chip cookies. And in any baking situation, Brandon thought, you can have the dough, you can have the milk, you can have the flour, sugar, etc. Mix them together, do that type of mix, and then we mix in more the chocolate chips. But we cannot mix the chocolate chips with everything, because otherwise it's going to be completely melted, the chocolate chips. So what we need to do is that we need to do, first of all, whatever the parent class would do. So you can see that super.mix is calling this method, the method that the three amigos decided to implement very carefully. Leon wanted 5 folds, so 5 folds it is. But then once we're done with that, then we mix in the chocolate chips. I just want to notice that actually you guys did see that mix and that you understand it. So with all that cookie work, then I would like then to hear if there's any numbers. Well, to hear the numbers here for this part. And if it has helped you guys understand more about inheritance. Great. Everybody's at 9. Okay. So then I'm gonna go a little earlier, 5 minutes earlier, because I don't want to interrupt concepts. Actually, you know what? No, let's go into instance of. This is the last concept before we break into the class break. So instance of is a keyword that allows us to review, and this is, if we're go back to this slide here that we were drawing, instance of, it will tell us if the iron, what was the iron, Sareth, that you suggested? Iron 1200. If we say iron 1200 instance of vehicle, what would it return?
True.
Correct. If we also said iron instance of truck, what would it return?
False.
Okay, what if we did iron 1200 instance of motorcycle?
That's true.
Okay, so you can see that essentially this is the path for us to return true on the instance of. That is useful for us to actually be able to define or understand if an object is type of another. Now, I think then that let me then I think this part is very straightforward. As far as like the keyword instance of goes. So let me get an understanding from you guys, a numeric understanding of instance of. How is that clicking with you guys? Perfect. I honestly wonder, like, you know, even if such a simple concept, you guys are not putting 10 just because you want to play it safe to say, okay, well, I understood, but I still want to play with it. So anyway, for now, let's pause here. Let's take 20 minutes and then let's come back at 8:18 just to continue, because the next part is something a little bit more intense, I would say. So I'll see you guys in 20 minutes. So far, we have discussed that this is where I go back, you know, to what we were to here, where we were talking about this slide, and I was saying that the higher we go here, I gotta switch windows. That the higher that we go on the this level, the more abstract, and here we go more concrete. And there's other dimensions that go hand in hand with abstract and concrete. One of those is the amount of code that we have. And actually, now that we understand, you know, when I put that abstract and concrete thing, we have abstract, we have concrete. And that abstract and concrete thing, there is the total code that we are going to be writing. This is going to be much more incomplete. And this is going to be complete. Then it's also the other dimension that that is affected by the abstraction is who is going to be our user, who's going to be using this code that we're going to write. So if it is complete, odds are that it's going to be a user, an end user. What's the difference between a user and an end user? Can anybody tell me?
Is the end user like a customer or something?
Maybe a user like an engineer using the code.
So when we go more abstract, we're going more towards selling it to an engineer who might be writing, like a plugin system or something like that. And then user is somebody that is actually going to use that code. So in Java, when it's fully abstract, when basically there is no code, we call it interface. And when it's concrete, we call it a class. Everything that we've been writing has been more on this layer, right? Everything that we've been doing has been down here. Now there is a third layer because we have like full abstraction, no abstraction, and there is an in between, some abstraction. And this is where I wish that the writers of Java as a language would have been a little bit more explicit or more careful with choosing their names, but they were not. So this is what I've got. So what these guys, what we do have with the in-between state, it's known as let's say inconclusive. And in the case of Java, actually, let me switch back to this guy. In the case of Java, the keyword to describe that in-between state is known as an abstract class. So it has some code, but not all of it. And when we are even on any of these, in the who section, if we are in these two things, likely we're going to be writing a plugin system or something. So can anybody name me an example of a system that requires plugins? Well, I take out this trash here. A plugin system.
A browser?
Yeah, exactly. Chrome has a bunch of plugins. So what, from a plugin perspective, if we're writing a plugin system, basically, just to visually explain it to you guys, it's essentially similar to a puzzle. This is a puzzle piece, and everything else is assembled. Everything else is assembled. Doesn't matter what many pieces we have, but the puzzle piece, this part is empty. And the only thing that it's left for us, just, Like if we're visualizing it like a puzzle with a missing piece somewhere in the middle, the only way that we know that that piece fits properly is if we have a piece with the same shape for it to be able to fit in that puzzle, assuming that these two are the same shape. So this piece goes there. And you know, if this was our plugin system, we could say that, you know, we have a sun and some mountains. But turns out that, and a little river, actually, just to go full Bob Ross here. But in the actual plugin system, we get the functionality that makes it unique. In this case, I'm drawing a house to, like, you know, make it visually analogous. But that's basically how a plugin system works. You just define the shape, and it's up to, you know, plugin writers to rewrite those plugins to that particular shape. And it doesn't matter who essentially writes them, as long as it fits, you can use that same plugin system. So I don't know, here we can put like somebody dancing and so on. So that's the way more or less like a plugin system works. So in order for us to know what the shape looks like, we got to define that shape. And this is where the no code thing exists. So if we go to our browser, I mean, to our IntelliJ, and right click, and we're going to do new class. And since I just went to get a chocolate, we are going to come up with, we're going to say that a chocolate is the name of the class, and we're going to have an interface. We're going to choose the interface. Why am I choosing chocolate other than the fact that I just had one? It's because chocolate, if you think about it,